I taught in several institutions, including the Johns Hopkins University. I left that work to start a generative language modeling company in 2014. Yes, they existed even before the Transformer. We had the interesting idea of fine-tuning these things on conversational data for our enterprise customers. And then a couple of years later, we realized that for one of our customers, CenturyLink, a pretty large telco, they were not able to deploy our model without giving it access to external data. So in 2018, we devised a system where we custom built a Chrome extension, filled a room of computers with no humans at the helm with Chrome extensions, and we pre-built 3 workflows in which our model had to write down the entry, the name of the person on the phone, and that system would just trigger and look that person up and tell them the remaining balance on their account and what options they had for payment arrangements. And we patented this idea in 2019 and called it the AI Communications Agent. So the concept of giving models, generative or not, the ability to reach out externally and systems around that model is frankly a lot older than people think. So there's a lot of things to learn. Now, again, if you've never been to one of my talks, I do like to kind of tell my piece through stories, and maybe you've heard this one before. But just not too long ago, Summer Yue, the director of alignment at Meta, was connecting to OpenClaw. If you've never heard of OpenClaw, I would Google it, but I'll talk about it a little bit more a little bit later. And she basically gave it a relatively simple task on a toy inbox. She said, handle my emails for me, and very specifically, do not action until I tell you to. Now, one day, she is, I believe, out to lunch or getting coffee or something, and she notices that her emails are almost all getting deleted when she moved from her toy inbox to a real email inbox. She starts telling OpenClaw from her phone, don't do that. OpenClaw did not respond. Stop OpenClaw. OpenClaw did not stop doing what it was doing. And she physically had to sprint to the machine to turn it off to stop all of her emails from getting deleted. So OpenClaw is, of course, not really a niche tool by pretty much any definition. It is, as far as I'm aware, still the most popular in terms of stars repo on GitHub, even surpassing things like React, Kubernetes, even Linux for 30 plus years. So OpenClaw is not some niche tool that Summer was trying out. It was the most viral agent project in the world. So I don't need to sit here and tell you, I can throw some stats at you, here are some of them, about agents and multi-agent systems already among us being here. You've already heard these talks about agents talking to each other on the internet, agents helping with default decisions and financial decisions. We don't need to prove to ourselves that people are trying to use agents. Now, of course, stats that are not on the screen are stats like 95% of agentic projects seem to fail, which I take as actually a positive, because that means people are actually trying and they're at least reporting their failures and being honest about it. So I actually take that kind of a stat as a positive. So enterprises are using agents. There's growth in the specifically multi-agent architecture system, and it's just going to keep growing at the rate that we are going today. So what do we mean when we talk about a harness? And there's a lot of definitions out there, and it's kind of hard to pin down the exact timeline. But roughly 2 months ago, in February of 2026, we start to hear this term around harness engineering, and what this thing around the LLM called a harness, the system, the tools, the evals, all the other stuff, the bells and whistles that goes around the LLM. I personally really like Vivek from Unchained's kind of quote-unquote definition, which is an agent is just a model plus the harness. If you're not the model, you're the harness. It's a little bit of a, it's a vague definition, I'll admit, but for the purposes of today, we're going to be talking about the harnesses of agents, and by harness, I mean, frankly, anything around the LLM or the model itself in question. And as I'm sure you've heard from many other talks before, models are becoming more and more a commodity day by day. I forgot who mentioned it earlier, but even in the last couple of weeks, we've had frontier closed and open weight models coming out, and it's only getting, in a lot of terms, only getting faster at the rate companies are putting out models, custom models, frontier models, so on and so forth. Now, if you've ever used an AI product, you've already interacted with a harness. In fact, it's kind of hard to conceive of any kind of AI product that does not have some kind of processor systems around the model itself, especially when you look at agents, notably ChatGPT, Claude Code, which is separate. We'll get to Claude Code in a little bit later, and even arguably, simple RAG systems are harnesses around models. So if you relax your definition a little bit of what a harness is and remove the concept of tool calling, function calling agents, the concept of imbuing an LLM with more context that is not inherent in the training data is itself a form of a harness. So where do harnesses go right and where do they go wrong? Let's come back to Summer for a second. Does anyone actually know that story about Summer? It went pretty viral. OpenClaw has a harness. That's not surprising. And it's a good one. If you go on the documentation, they'll tell you all about it. There's identity focuses, capability focuses, memory focuses. And this is a pretty mature harness by kind of standards and enterprises today. I still make agents and multi-agent systems for Fortune 100 companies. They looked a lot like OpenClaw even before OpenClaw existed. So we've come to, for now, a consensus around what are the components of a relatively good harness, which tend to break down into identity, capabilities, and memory. Does anybody know what went wrong with Summer? I'll give you a hint. It's on the slide. One of these components of the harness failed her. And it's not really her fault. It's not really OpenClaw's fault. It's just a mismatch of the harness component and the task being asked for. Does anyone actually know what went wrong? The rules? It was not the agent's MD. According to her, at least. I mean, it's a little bit of self-report, but one more, yeah? It wasn't the incentive. It's a lot simpler than that. One more.
Memory, no?
What kind of memory?
Context?
What kind of context? It's on the screen. List one of the bullet points under memory. It was the auto-compaction. What had happened was, Summer had told the AI in context, in short-term memory, which is why I was pressing you on it, in their short-term memory, meaning the context window, don't do things until I tell you. It wasn't in the agent's file, it wasn't in the soul file, it wasn't in the memory file. And what had happened was, when OpenClaw auto-compacted its context window, which Cursor does that, Claude does that, that's a pretty standard feature in most harnesses today, so to not fill up the context window, it got summarized away. And that concept of she had no idea because she doesn't know when the auto-compaction is happening. She doesn't know what's getting compacted away and what's staying. And in this instance, again, according to Summer, the inbox was so huge, it triggered a compaction which lost the original instruction. So who failed? Did the harness fail? Did Summer fail? It's kind of hard to say, because you could argue that if these instructions were somewhere more persistent, like in the long-term memory stores in the agents.md file, this would have been less likely to happen. So when we talk about a harness, it's not just, did you make one? Is it good? But it's also going to be about, are the harness components triggering when they are kind of relative to the task difficulty and the autonomy granted to the agent. Now, my book, which there's a signing a little bit later, is effectively a compendium of anonymized case studies from the last 10 years of building agents. One of those, one of my clients had asked me to build a complete end-to-end SDR system with multi-agents. We need something to lead generation. We need something to email these things. We need something to follow up if that's going to happen. How do we automate this process, this kind of cold email outreach process with agents? So as one of my examples in my book, kind of simpler anonymized version of that, I made one to sell the book I was writing. So find professors, find lecturers, find teachers who may need to use my book to teach agents, who may enjoy using my book to teach agents, and send them a cold email given a template I've already written. One morning, I woke up and found in the CRM a bunch of retired professors, close but no cigar, non-teaching staff at universities, and I go, okay, it's generating leads, but it's not really qualifying them. So I fixed it. I added an agent. I threw an agent at the problems that, okay, well, let's take a page out of the sales textbook. What comes after generation? There's usually even another human being for qualifying that lead to it so that it gets filtered out if they're not very good quality. So I added a lead qualifying agent to move down the kind of the normal sales funnel. Each of them had a heartbeat. They woke up. They did their work. Everything got a lot better. But I had a new problem. As these things are waking up on relatively similar heartbeats, they're doing work, they're passing information through the system of record, I wanted to ask questions like, how's it going? Who's responding? Any insights that you have? Who do I ask? Do I ask the emailing agent? Do I have to ask the generation? Who is the right person to ask? So what did I do? I threw another agent at the problem. And this time I followed a pretty standard harness for multi-agent architectures, which is an orchestrator, which is different than a supervisor. We'll get to that in a moment. An orchestrator's job is to take domain-specific subagents and delegate tasks from the system of record to those domain-specific systems. So the orchestrator had a heartbeat. The subagents did not. The orchestrator would wake up, count with my instructions, look who's in my HubSpot CRM, tell me who's new and not qualified, give them to the qualifying agent to do the qualifications, move leads down the funnel by invoking the correct sub-agents. And now I had a single entry point to ask questions. You have access to the system of record. You're not really doing any work to help me sell the book. You're just really orchestrating the agents who are now the workhorses of the system. So when we talk about harnesses and multi-agent patterns, there's a lot more than 3, but it kind of boils down to 3 main types. And in fact, if you were here for the NANDA talk, the first one is kind of where they are focusing, the future of free-form networks. How do you bid for intelligence? How do you compensate, whatever that means, to an artificial intelligence? How do you compensate agents for knowledge? And as of today, in April of 2026, free-form networks are not very consistent. They're not very easy to scale. And until we kind of fix and figure out a lot of those problems that, to be fair, people like the organization at NANDA are trying to figure out, we don't really know what to do with it. So until then, we tend to focus more on orchestrators and supervisors as the main coalescence of multi-agent harnesses. Orchestrators, like my SDR, have specialized subagents whose job it is to move things through a system of record. And of course, you can remove the system of record. It would still technically be an orchestrator. But having a system of record, a single unified ground truth that the orchestrator can actually look at for what's going on in the system, tends to make an orchestrator the most powerful network. Then there's supervisor and subagents. You've most likely interacted with this more often than not. This is Claude Code. This is Cursor. The ability to spin up ephemeral scoped agents on demand it tends to be what defines a supervisor agent. They can spin one up, ask it a question, make it do work. They wait, usually, for the subagent to finish, and then they can move on. So we have these patterns in multi-agents, but OpenClaw isn't even a multi-agent by default. By default, it's a single context window, a single choke point for short-term memory, and this is how you have those failures between the harness exists, it just didn't work for Summer in that moment. Is it because she didn't use it correctly? Again, that's debatable. Frankly, anyone could have made that mistake that Summer had made if they don't quite know the rules for how things get compacted. So when I think about building a harness, I tend to think about it in 2 dimensions. There's a second graph coming up a little bit later. The first one is autonomy granted versus the safety capabilities. So for example, Summer's example in the bottom left started at pretty low stakes. It was a fake email inbox effectively. Same harness, she didn't change anything, but eventually she just switched from toy to real. So she moved up the quadrants, she granted more autonomy, but didn't change the way she was using the harness, and that's where things got dangerous. Meanwhile, in my SDR system, I started in the top left. I did not build a very strong harness for the SDRs. I noticed them not really doing good work, and without changing the scope is still email these people, sell my book. That's a fair amount of autonomy. I simply increased the guardrails of the orchestrator pattern to get better results. And when we think about it in these quadrants, I tend to think about it as you want to be moving, ideally towards the diagonal, kind of depending on where you are in the quadrants. You don't want to over-engineer things. You don't want to be in the danger zone. But figuring out what the right amount of safety harness is for the task you are completing is one of the dimensions we can think about. Now, the second dimension we would think about outside of safety and autonomy is capabilities. This tends to be the other place where harnesses shine. I'll give you, if you've not been following Claude Code in the last couple of months, they've been busy. Not necessarily in a good way, but they've been very busy. Even as late as last week, they have been fixing and reverting code and bugs introduced not by the models that they've been releasing, but by the harness. In March, they made in March and April, they made 3 main changes to the harness. They, without really telling the world about it and announcing it, they dropped the reasoning from high to low to fix latency. They reverted that on April 7th. They had a bug in their harness that would purge the thinking tokens, trying to help you save some cost here. They fixed that on April 10th. And they also changed the prompt to tell it to be less verbose. Again, clearly people are spending a lot of money. They're trying to help you out here. So these are instances where the model itself didn't change. I was first told this by one of my clients. Shout out, thank you, Tommy. I know you're watching. This was pointed out to me by a client, because I don't personally use Claude Code. I prefer Cursor for what it's worth. But one of my clients said, what happened? Claude Code is getting worse, and I didn't change the model. It's not the new model. I don't know what's going on here. And I go, I don't know either. And then when I did that deep dive a couple of weeks ago, and I had to add to it last week, I noticed that their postmortem was saying, we had a lot of bugs in the harness. It wasn't the model. We had changed the harness, and things got worse. We had to fix it. But the reverse can also be true. LangChain's deep agents, which is itself kind of an off-the-shelf harness for agents built by LangChain, they saw, in a singular cherry-picked example, I should be very clear, the opposite. By updating their harness, by adding more components for the task that they are trying to perform, in this case, for the terminal benchmark, self-verification, meaning reflect on your answers before you do anything. Context optimization, under which auto-compaction would fit under. Middleware hooks, which is actually a new feature in LangChain agents, allowing you to write custom code before and after model and tool uses. They were able to increase the performance without changing the underlying models at all. So when we think about harnesses, it's not just about safety, it's also about capabilities. Anyone familiar with Cognition's Devin? I like to use them a lot in my talks. So the long story short of Devin is in 2024, they put out this arguably monumental graph in which they blew the competition out of the water on the software engineering, the SWE bench, with a whopping 13.86% on the benchmark, which, to be fair, was beating Claude 2, which was the latest Claude model at the time, raised a bunch of money from Peter Thiel's VC, and are now valued at north of $10 billion. Now, the problem was that over the next year, in 2025, a lot of case studies started coming out about Devin and not really living up to the expectation, which, for what it's worth, if 13.86% was the expectation, I think they nailed it. Now, to their credit, and to their self-reported credit, in the last year, roughly late 2025 and early 2026, but this was reported as of late 2025, they made a lot of improvements on their system. But they don't make models. They make a harness. They added, again, like on the screen, things like interactive planning, parallel execution, sub-agent dispatching. That's the supervisor pattern that we talked about previously, and there's more if you want to read about it. But they don't make models. They make a harness. So they're able to get better performance. I should hope so. They're worth billions of dollars. They're able to get better performance simply by adjusting the harness for the difficulty of the task they are trying to perform. So in a similar quadrant style, I would also think about harnesses from the perspective of the capability that the harness provides versus the task difficulty the LLM or the agent system is attempting to perform. So it's not just I'm granting you autonomy. It could be a low-stakes system, but it still needs to do the thing I ask it to do. And whether that's bringing in external context, agentic RAG, or something more complicated like in my own personal example, my startup Crucible focuses on both fine-tuning models and building harnesses to help people perform machine learning engineering tasks. So the concept of adding capability through a harness, most notably these days through a supervisor sub-agent spawning style system like Claude Code and Cursor, that's not for safety. That's for capabilities. That's to get more done on maybe a higher budget, but it's not to grant more autonomy, it's to make the system better. So Devin is not doing anything new. It's the same promise of the system, but they made the harness better. Same with Crucible. And if you think about earned competence from a harness perspective, this is where I think a lot of people get this wrong. They think they just land somewhere on this quadrant and then they kind of call it a day. You are moving through these quadrants. You are updating your harness. You are updating the autonomy granted to your systems. And you want to be thinking about this from a progressively earned competence of your harness. Now, as the name of the talk suggests, I do want to make a case against too much harness, because that concept does exist. And when you talk about too much harness, usually the standard things come up like approval fatigue is the number one. Well, the number one I see is just more failure points, the one in the middle. That's the Claude Code example. The more harness components you add, to no one's surprise, I hope, there's just more failure points. How do you know you're invoking the right harness capability in the right moment? Do you even have the right harness capability for the tasks being performed and the autonomy being granted? So as you expand your harness, you are introducing more failure points. And when you introduce more failure points, you have to do testing and evals, and now everyone's asleep. So it's really difficult to think about all the different failure points that you are just seemingly adding. Every time you add a tool, you are adding multiple failure points. What if that tool fails? What if the agent asks for permissions it's not technically supposed to have? How do you red team this? Those kinds of failure points are frankly easier said than done in the 25 minutes I have up here. But there's also approval fatigue. A lot of people will say, well, let's make this as safe as possible and ask a human as much as possible for all the work the agent is doing. In theory, great. But I have seen the opposite end of that spectrum where they take it a little too far, and then people start hating the agent system because everyone now feels like they're babysitting this thing, which is either doing a fine job, don't ask me for this, or it's doing a not so great job, and all I'm doing is correcting an AI all day. Is this my life now? So the concept of approval fatigue is not going to say rare, but more uncommon, but it's definitely something I see being acted on at larger enterprises. Let's just put more humans in front of this thing and call it a safe day. Guardrail overfitting is more in the middle in terms of commonality, the concept of, well, by adding these tool level or harness level guardrails, for example, MCP has a concept of roots, where the server can tell the client and the host what workspaces it has access to. But by doing so, you introduce the concept of over-refusal, meaning if the agent says, these are all my capabilities, I cannot deviate from these capabilities, a model update like Opus 4.7, who they specifically called out, our model is so much, quote, better at instruction following, if you really didn't tell it what it can or cannot do, it will refuse. So this concept of over-refusal is both in a model in the way you train it, but also can be introduced by the harness. So when you are building the harness, which is, again, by our definition, anything that's not the LLM. So if you are building code around an LLM, you are effectively building a harness for your AI product, or most likely an agent. Think about your potential impact. You've probably heard this term more as the blast radius. I try to avoid terms like that. But potential impact of the AI product in the system itself. Is it low, medium, high? Is it reversible? Is it observable? Is it irreversible? And of course, depending on what you're doing, drafting an email, sending the email, replying to emails, will fall under one of these rows. And then what the harness might, not should, might need to include, depending on your task, will follow. More than that, when we talk about patterns in these harnesses, again, it's easy, well, quote, easy, to rattle off a bunch of things like, okay, well, make sure you have your embeddings, make sure you have a hybrid search, make sure you have your memory.md, and again, we can debate whether each of those individually work for your specific use case. But the way I try to think about it is, again, movement. You're testing, you're iterating. Again, that stat, 95% of these agents fail. Well, hopefully the next iteration doesn't. Just because this iteration of your agent failed, maybe your harness was wrong, maybe the model was wrong, you didn't test it enough, that's okay. You are moving through earned competence. By setting up evaluation loops as soon as possible, agents judging other agents' works, multi-agent reflection, targeted evals, not just open source benchmarks, that will inform your performance controls. Okay, it sucks at this, let's rate a skill for it and give it to it. Okay, it's not very good, or rather it's very good at this, but it's way too expensive. Maybe this one specific subagent should be a cheaper model. So by setting up these loops, you are informing your own performance controls of your harness. Similarly, by adding in observability and human in the loop, which again, I am not advocating against, that is allowing for progressive autonomy. Your autonomy scales with evidence. What is your harness agent good at? What is it bad at? what can we do to improve the harness around capabilities and safety and give it more and more autonomy? So you move upwards in that chart of autonomy granted. Your harness scales with impact. Your autonomy scales with evidence. So given all of that, picking a harness and the harness components is, quote, as easy as asking Claude to look up good harness components out there and figuring out what works for your task and collecting evidence, writing evals, working with your ML team. No one's saying you don't do that. My big takeaway from years of work in agents, even before the transformer, is this is earned competence. This is not something you come up with on a lab, even with several months of research, and say, we're done. You are progressively trying to add in these gates and then remove them as you learn what your system can and cannot do. So with that, I'd love to take some questions, but that's my case for and against harnessing these agent systems. Thank you.
Yeah.
Yeah, questions? Yeah, please.
Love the idea of the earned competence. Can you talk a little bit about what happens when, like love and logic, raising a kid? Ideally, when you raise the kid early, you teach them to fail early, they don't fail big. What happens if it's earned competence and then fails big? How do you work on kind of remediating that?
Earned competence, but then it fails big. It sounds like that would fall under one of two main categories, which is, one, it failed big at something you thought it earned competence on, versus it failed big on something it did not earn competence on, and maybe you didn't expect it to even attempt. Two very different ideas. Did you mean one of them in specific by any chance? Was it the former? Okay, I'll do both. So if you earn competence in some task and the agent all of a sudden fails very hard at it, usually, it will fall under one of the categories of, well, did it follow my instructions way too literally and then miss some blind spot? Again, this is where your observability comes in. Figuring out why agents fail, the behavior of the agent, the trajectory of the agents, the outcomes of the agent. Those concepts of agentic evals will tell you why. It's a lot easier said than done, and then you update your harness. Again, obviously, hand-waving away a lot of work there. In the second case, where the agent attempted something it did not earn competence in, where were your guardrails? Who told it what it couldn't do? In my book, in my talk, I call this the behavior of the agent. Is it listening to me when I tell it what it can and cannot do? There's a case study in the book where I tell an agentic RAG system to always look up a policy before answering a question. GPT 4.1 did that 95% of the time. Why? Why did you not listen? There's no compaction here. The system prompt was 3 sentences long. Always look up policy information, even if you don't think you need it. It still didn't do it for 5% of the time. These architectural limitations, like, sorry to drop some words here, but positional bias, lost in the middle, the needle in the haystack, means these AIs are not going to listen to you 100% of the time. So do I force the tool call? Do I force the system? Well, now I'm just building a workflow at that point. And you have to find that balance. I know I answered your question for a long time, but do you want to do a couple?
Yeah, we'll do one more quick question. One more quick question. Anyone? Otherwise, you can catch Sinan in the hallway.
Oh, there's a text me. Don't text me.
And also, remember, Sinan has a book signing coming up this afternoon at 3.
Great talk. If anyone here wants to, it's like a simple question. So I'm still stuck on the summer story. And then you mentioned that in the end, she tried to prompt it to stop OpenClaw, do not delete. Was it like a positional bias why it didn't follow those instructions?
From what I understand, we don't know that level of detail as to why it was ignoring, at that point, why it was ignoring. If I were to, frankly, educated guess, it was either that the messages coming in were too late, it had already done the bad things, the agent just didn't reply because it had already done it. Or what's probably more likely is that once the agent calls those tools, depending on the model that she was using, once the agent calls those tools, the model has seen in its context window, it called it, and it succeeded. It now is more likely to assume, I'm allowed to do this, I've already done it. So even when you tell me to stop what? I don't know, I'm just doing my work. Like, you didn't tell me what to stop. She just said stop. She didn't say stop deleting my emails. She just said stop. Okay, I'm doing my work, but I guess I'll stop. But maybe the damage was already done. So we don't know exactly why, but most likely, it is a combination of the damage was already done, and the agent had already done it. Therefore, it had seen it in its context window, which is a form of kind of contextual limitations of the model, which is, well, of course I'm allowed to do it. I've already done it. I know I sound very malevolent of the AI, but
Everyone, let's give Sinan a
Thank
big
you all so
round of
much.
applause. We really appreciate it, Sinan. Awesome stuff.